Okay. Welcome back. Vikas Nandwana is joining us now. He is a postdoc in material science at Northwestern University. Welcome.
Thank you.
So tell us about your work.
So I'm working to develop a technology which can detect and treat cancer in a more effective way. So the current technologies which detect cancers are not based on targeted, because once you inject the medicine, they go all over the body. So what happens is they just not only cancer cells, they also affect the other normal cells. So that results in a lot of side effects actually. So like the most of the technology is based on radiation or chemotherapy. So that is not very effective. So what we are doing is we are trying to develop magnetic nanoparticles. Basically, these particles are very smaller than cells, cancer cells, but bigger than DNA. So what you can do is you can pack a lot of particles in a cells, and they have some specific receptors which can just go and stick to the cancer cells. Just like think of a missile, if you shoot it, it just hits the target. So they don't affect any normal cells, and then they are very effective for the detection as well as the treatment.
So tell me how you would use these nanoparticles to detect cancer.
So yeah, these are magnetic nanoparticles. So they are made of basically iron oxide, and iron is completely good for our body, so it's not toxic. And since they are magnetic, you can visualize once they are inside the cells. You can visualize them in a tumor using MRI, which is a well-known technique, and then also these particles can carry some sort of chemotherapeutics. So once they are inside the cancer cells, you can even deliver the cancer cells right in the tumor.
And how far away is this from actually being available to patients?
Currently they are using for mouse trials in mouse and rabbits. So the technology works, it has been tested, but it might take 10 to 15 years to go to the humans before we can validate it. The trials.
So what are the big challenges in doing this kind of work?
Yeah, so as you can imagine, each cancer is a different cancer, so that's a big challenge, that to develop a particular receptor for a cancer cells and developing a procedure to reach to the cancer cell, because that's why there are patients for like prostates where the rate of death is much higher than lung cancer. So that's a big challenge. To each cancer is a different type. So there's not a one cure for all. So we need to develop a different tools for different cancers.
So which cancers have you worked on so far?
So currently we have worked for 4 different type of cancers: lung cancer, liver cancer, lymphoma, and brain cancer. So, but I think what I would like to add also is that not only cancer, because this technology we can also use for other diseases like cardiovascular. Because once you can target any disease, you can visualize under MRI actually.
How about viruses? Can you use it for infection?
For sure, yeah. If they are on the right size, because in nanotechnology, this is very important, that choosing a right size. Otherwise, your body does not accept that and just takes it out.
All right. Well, thank you very much. Good luck with your research.
Thank you very much.
Nice job.